So welcome to Statistics 21. Today we're going to talk about the binomial probability formula, and we're going to kind of discern where it comes from and how it works, and then in general I'm going to show you how to use a calculator to do these probabilities. It's much simpler than using this formula, but understanding the formula helps us understand how these probabilities come about, so it's fairly important to at least do that. Okay, as you can see below, I've written the formula, and you will notice that it is a combination of n things taken x at a time. So what we need to remember is n that was equal to the number of trials in a binomial experiment, and x is your random variable that you're talking about, your specific random variable, and p and q then are the probability of success and the probability of failure. So we have the four variables that were used for a binomial experiment in yesterday's video. Now, as you can see, it's a combination of n things, the number of trials, taken x, specific random variable, at a time. Then you take the probability of success and raise it to the x power, and the probability of failure and raise it to the n minus x power. And then basically, if you'll remember, this part is just the combination formula for n things taken x at a time. Now, that's the basics of the formula. So let's go on and talk about how it works and why these parts come about the way they do. So I want to explain this example as we get started. First of all, we're going to have a binomial experiment. And that experiment is, I want to draw 3 cards from a deck. I want to draw those cards one at a time with replacement. In other words, I'm going to re-put the card in the deck and shuffle it. A success is going to be drawing a heart. Alright? A success is a heart. Now, what I have made over here on this page is I've made a tree diagram of this experiment. And so what you can see in the tree diagram, and this is from our probability, is that I get a, let me make this a little brighter color, I get a heart and then not a heart, and then the probability of a heart is 1/4 and the probability of not a heart is 3/4. And you can see that after I replace the card that the probabilities are going to stay the same for a heart or not a heart, etc., no matter where I pick it out on the tree diagram. Each level of the tree diagram, this represents the first card, this represents what happens on the second card given whatever happened on the first, and this represents what happens on the third card. So here's our typical tree diagram with probabilities labeled. Now I'm going to show you why and how the binomial formula works so that you have some understanding why you need all 3 parts. So what I have here are the outcomes of this experiment. Now I haven't listed them all. There are 8 total outcomes, 1, 2, 3, 4, 6, 7, 8, and I've listed 4 of them. The first one I listed is getting 3 hearts. The second one, or the next 3, are getting 1 heart. So I get a heart, no heart, no heart, no heart, heart, no heart, and no heart, no heart, heart. And so those represent those. Now, if I look at the formula, what the formula has is it has a combination part on the formula. So it's n choose x. And in our problem, that would be a combination of 3 trials, and then x would be whatever random variable. So if I said I want to get 3 hearts, then what's a combination of 3 choose 3? If you have your graphics calculator, you'll see quite easily that's 1. If you do it by the combination formula, you'll see also quite easily it's equal to 1. And so that tells us that there's only one way to get 3 hearts. Or I could say a combination of 3 trials, but I want to get 1 heart. Now I can see by listing the outcomes that the answer has to be 3. And by working through the combination formula, I will see that if you choose 3 at a time, you'll have 3 factorial over 2 factorial times 1 factorial, which is equal to 3. And so the reason the combination portion is in the formula is it helps us figure out how many ways we can make that happen. And so the next part of this is, once you figure out how many ways, then you have to ask yourself, what's the probability? Well, the probability of getting a heart is 1/4. Well, the probability of getting another heart is 1/4. Probability of getting a third heart is 1/4. And so that is equal to 1/4 to the third power, or if you wish, the probability of success to the third power. Did we have any failures? No. So that's 3/4 to the 0 power. All right? And that's why you get the p to the x, q to the n minus x. In our case, x is 3. I had 3 hearts. And n is 3, so 3 minus 3 is 0, q to the 0 power. And that's why that part of the formula works. So if you were asked what's the probability of getting 1 heart, then this is the information you need to know. You need to know n, you need to know x, you need to know the probability of success, and by consequence you'll know the probability of failure. Okay. Let's stop there for a second. So to finish our example, I want to show you 2 quickies and how they fit in the formula. The first one is, what's the probability of 2 hearts? Well, from before using that experiment, I would say the probability of 2 hearts is a combination of 3 trials taken 2 at a time getting a heart, then p, which is 1/4, I want to raise that to the 2 power, 2 successes, and then 3/4 I want to raise to the first power. And now if you work through this, then a combination of 3 choose 2 is 3. 1/4 squared is 1/16, and 3/4 to the first is just 3/4. And so when you multiply this all out, you get 9 over 64 is the probability of getting 2 hearts. What's the probability of getting no hearts? Well, that'll be a combination of 3 choose 0, 1/4 the probability of success to the 0 power, and then 3/4 the probability of failure to the third power, since no hearts is a failure. And how's that worked out? Well, a combination of 3 choose 0 is 1, 1/4 to the 0 is 1, and 3/4 cubed is 27/64. And therefore what we have is, in this case, is the probability of no hearts is equal to 27/64. And that's how you do it when you use the formula. So what you're going to see is on the calculator we want to use a formula called the binomial PDF. And what this will do is this will find the probability of one random variable. Tomorrow we'll talk about the binomial CDF, which will find the sum of probabilities, cumulative probabilities for a random variable. Now, on the calculator, how do you do this? Well, basically you press the button second, and then the button VARS, VARS, which is right over by your clear under the arrow buttons. And what that will give you is the menu called distribution. And under the distributions, if you go to number 0, which is 10, then you will find the binomial PDF. And just so you know, the binomial CDF is right after that. So how does this formula work? Well, all I would have to do is, because it has the syntax, the format of NPX, which is number of trials, probability of success, and the exact random variable you want, then for our first problem up here, the probability of 2 hearts, I would enter binom PDF, and that's what will show up on my calculator is like that. Then I would enter n, which is 3. The probability of success is 1 divided by 4, or you could put 0.25. And then the number of successes was 2 hearts. And I would click that, and it would give me the answer, 0.140625. And just so you know, that's equal to 9/64. So it gives me exactly the same answer as the formula listed up above in the box. And that's how we use binomial PDF. If I wanted to do the second problem, then I would change this from a 2 to a 0. And if I wanted 3 hearts, I would change it to a 3. If I wanted 1 heart, I would put a 1, or 2 hearts as we had, I would put a 2, and then it would give me that probability. Okay? Any questions? Make sure you bring those to class, and I can show you this on the screen if you like, just so you can see it once too. So the next calculator statement is the binomial CDF. I just decided from the last slide that I should do it now based on the problems in the textbook. So the binomial CDF is found much the same way. You do second on the calculator, press vars, which will give you the distribution menu, and then letter A is the binomial CDF, and you can scroll to it and press enter, and that'll give you the binomial CDF. You will also notice that the parameters of the binomial CDF are again the number of trials, the probability of success, and a random variable. But what's the CDF do that the PDF doesn't? The PDF is an exact probability, so it finds the probability of 0, the probability of exactly 1, or exactly 2 successes. What the CDF does is it's a cumulative probability. So it finds the sum of the probabilities for the random variables for 0 up to x. So if I go to my calculator and I do, apologize for that, something was burning in the oven. Alright, so the binomial CDF, and on our last problem, suppose I want to know the probability of getting 2 or less successes. So I would type that in here, and it would look almost exactly the same as what I typed before. It is exactly the same, except for the C. But what this figures out is the probability of exactly 0, exactly 1, and exactly 2 successes, and it adds them all up to that point. And so if I were to figure that out right now, I would get this, excuse me, 3, 1/4, 2, the probability I would get is this would equal 0.904 and a few more decimal places. So in other words, there's a 90% chance that I would get 0, 1, or 2 successes. if I was trying to get hearts from a deck of cards. Binomial CDF. Okay? Now, another way I could do it is, what if somebody asks, what's the probability of at least 2 successes? Well, at least 2 means the probability of 2 and 3 successes, 2 or 3 successes, excuse me. And so one way to do that, instead of finding exactly 2 and exactly 3 and adding them together, one way we could do that is do 1 minus the binomial CDF of 3, 1/4, 1. So in other words, we add up from 0 to 1 and get that probability and then just subtract it from 1. And by doing that, you end up with exactly what you would like. And that's kind of a nice feature, and it uses that complementary probability which we used in the probability unit. Now I'm probably going to do one more problem in class that refers to this video, and just so you know, that probability is about 0.156, so a little, almost 16%. And so, but the problems I'm going to give you today involve this. And I'd like to assign the problems, I think I'm going to assign, just so you know that before you come to class, problem 16, problem 16 through 24 even. And that'll be what we're working on tomorrow. And then tomorrow we'll get around to doing the graphs of binomial probabilities. Okay, thanks.